How do you convert bytes to a string in Python is one of the most asked, most upvoted, most viewed questions on Stack Overflow. And what better way to hack the algorithm than to answer a question that's already been answered 1,000 times before? So welcome to Mcoding, I'm James Murphy. Let's talk about strings, bytes, why they're different, and how to convert between them. Strings and bytes look very similar in a number of ways in Python. You can make a string literal between quotes, and just add a b in front to make it a bytes literal. You can also use single quotes for either one, or single or double triple quotes. They both support escape sequences like \n to make a new line, and they both support putting an r in front to ignore escape sequences. One difference is that there are f strings that allow you to interpolate variables into strings, but you can't do f bytes, but that's a pretty small difference. And the types have a huge number of functions in common. Here I'm calling dir to give me all the attributes of the string and bytes types. I convert those to sets and then use the ampersand to get the set intersection and then print them out. And they have so many different things in common, everything from addition to finding, replacing, stripping, splitting, partitioning. They both seem to have most of the traditional string functions. Replace the ampersand with a minus to see the functions that string has but bytes doesn't, and it's really just a few. And swap bytes and string here to see just the bytes functions that string doesn't have. There's literally just 4 functions. But in spite of offering such similar functionality, Python seems to make a point of keeping them very separate. If I open a file in text mode, I have no trouble writing strings, but trying to write bytes will result in an error. If I wanted to write those bytes, I'd have to call decode to get a string and then write that. If I open the file in binary mode, then I can only write bytes. This time attempting to write a string will give me an error, but if I wanted to get the string, I would just call encode to get equivalent bytes and then write that. So if strings and bytes are so similar, why is Python insistent on keeping them so separate? And what's the difference between them anyway? Strings are just made up of bytes after all, right? Well, yes and no. To see the difference, let's take a look at a smiley face. But first, a message from this video's sponsor, me. In all my years of working with myself, I can say I truly recommend my own services. My team does Python and C++ consulting, contracting, training, and interview prep. If you have a project that you'd like to get some outside eyes on, check out mcoding.io and reach out to me. Anyway, back to strings and bytes. Is a smiley face a character? Well, when I run this function, it appears like it is. It seems to act like any other character. I can print it just fine. And Python says that there's just one character in the string. But if we try to do the same thing with a bytes literal, it doesn't allow us. It tells us we can only use ASCII literal characters. Okay, well instead let's try encoding the string to convert it to bytes and then printing that. \x is an escape sequence to give a hexadecimal number. 2 hex letters is 16 times 16 possibilities, which is 256, otherwise known as 1 byte. So that means that the encoded form of the smiley face contains 4 bytes. We can even loop over the bytes object to see what the 4 numbers are. In particular, although the length of the string was 1, the length of the bytes is 4. And while we're at it, how do we know that these 4 bytes correspond to a smiley face? After all, they're just 4 bytes in memory. How do we know that they don't actually correspond to the integer made up of those bytes? Or we could interpret those 4 bytes to get yet another integer that those bytes represent. Or maybe there's some kind of floating point number, or a 32-bit pointer. How do we know what those bytes actually mean? The answer is that a sequence of bytes on its own doesn't carry any meaning. If I just gave you a sequence of bytes, there are an infinite number of possibilities for what they could mean. It's completely up to you to determine what the bytes mean. And that is the reason that string and bytes are different. Strings are made up of characters. A smiley face, the letter A, the number 7, these are things that have meaning to us outside of computers. But of course, anything that we actually store on a computer does ultimately have to get translated into ones and zeros. So a bytes object is meant to store a raw sequence of bytes as it would be stored in memory. But a string stores an interpretation of those bytes in terms of characters. So when I ask Python to decode a bytes object, I'm telling Python, this isn't just random memory, this is a sequence of characters. Tell me what these bytes mean if you were to interpret them as characters. But there's still a piece of the puzzle missing. Who determined that these numbers mean smiley face? and that these numbers mean ABCD. This is the job of what's called the encoding. That's encoding, not M-coding. The encoding is a bidirectional map that gives you the sequence of bytes that corresponds to every character. If you don't specify the encoding, Python will use the default, which is UTF-8. UTF-8 is by far the most common encoding across all programming languages. At the time of recording, it has upwards of 97% market share. It's a worldwide standard about how to interpret bytes as characters, or more specifically, what they refer to as code points. And the name stands for Unicode Transformation Format 8-bit, commonly referred to just as Unicode. It was developed as an extension of the very popular ASCII encoding so that we could include more characters, like letters from many different languages, and of course, everybody's favorite emojis. But even though UTF-8 is by far the most common, there are other encodings, and this can be a huge source of frustration. In Python, by default, encoding a string into bytes or decoding a string from bytes will use UTF-8 if you don't specify the encoding. But when reading and writing files, it'll actually use the system encoding by default, which on my machine is not UTF-8, so if I try to write something that has a smiley face in it, then I get an error. I can fix this issue by explicitly specifying the encoding. Now when I write the file and read it back, everything works. Not specifying the encoding can also be an issue if you write the file on one computer that has one default encoding and then try to read it on another computer that has a different encoding. Let's say I wrote it as UTF-8 but tried to read it as this second most popular encoding. Very unfortunately, I don't get an exception in this case, I just get a string with garbage on the end. This is one of the worst classes of errors to run into, because aside from printing things out, I won't have any indication that anything is wrong, and now I may be feeding this garbage data into other functions, which could result in wrong things being displayed to my user or potentially bad data being fed into a calculation. If I switch to yet another encoding, this would be the luckier case where it actually detects that something is wrong. So what I recommend is if there's an option to specify encoding, just always specify it and use UTF-8 unless you have a really good reason not to. If you're using Python 3.10 or later, you can run Python with this -x warn default encoding. Doing so will run your program as normal, except it will also print out an encoding warning anytime you forget to specify your encoding. Alternatively, in Python 3.7 and later, you could run with the UTF-8 flag. This will basically make Python treat UTF-8 as your default encoding, even if it's not. And fun fact, look up pep 686. This is an already accepted pep that's going to make UTF-8 the default in Python. The only catch is that it's scheduled to become the default not in Python 3.12, not in 3.13, not in 3.14, but in 3.15. So put that on your Christmas list. Anyway, I hope this has cleared up the difference between strings and bytes for you. A bytes object just represents a literal sequence of bytes in memory with no interpretation, whereas a string uses an encoding, like UTF-8, to interpret those bytes as a sequence of actual characters. Don't forget to slap that like button, leave a comment, and subscribe. As always, thank you to my patrons and donors for supporting me.